Okay, in this video we're going to look at question 13 and then we're going to look at one of the free responses. So look at number 13. It says that f of x is e to the 2 over x. Now, I don't like that, so I'm going to rewrite that as e to the 2x to the minus 1. Because if x is on the bottom, that means really it's just a negative 1 exponent. So let's take the derivative. Remember that the derivative of e to the u is e to the u times u prime. So the derivative of e to the 2x to the negative 1 is e to the 2x to the negative 1 times, and then I need to take the derivative of that part. So my negative 1 comes down, now it's a negative 2, and then my power here, when I minus 1 more, becomes an x to the negative 2. Okay, then from there, I can write this as e to the 2 over x times, and then this is now a negative 2 over x squared. And so then if I'm looking at my answer choices, that is the same as answer choice D. Okay? Alright, let's look at the free responses, please. We are going to do let's look at free response number 2. Okay, so this one right here. Okay, so it says in part A, write an equation for the line tangent to the graph of f at x equals e squared. So if I want an equation of a tangent line, part A, there are two things that I need. I need a point, and I need a slope. Okay, my point, they tell me that x equals e squared. That's the x value of my point, and I need to find the y value. So I'm going to take my e squared, I'm going to plug into the original. So f of e squared is going to be the ln of e squared over x, which is also an e squared. Now, you can leave it like that if you want to, but we just covered this, so we know that ln and e cross out. So really, this is just 2 over e squared. Then I need my slope. I'm going to plug into f prime. Most of the time they don't give you the derivative, but here they did, so we're going to use it. So f prime of e squared would be 1 minus ln e squared over e squared squared. So notice I'm using this formula right here. So it would be 1 minus ln of e squared. Well, ln and e cross out, so really that's 1 minus 2. E to the 4th, because I have 2 times 2 there is 4. So really that's a negative 1 over e squared. To the 4th. So from there, I'm going to write the equation of my tangent line for part A. It would be y minus 2 over e squared, negative 1 over e to the 4, x minus e squared. That would be your final answer for part A. Okay, for part B, it says find the x-coordinate of the critical point of f. Now notice, that is not plural. That means that there's only one critical number. Okay, to find a critical number, remember that I need to set f prime of x equal to 0 or undefined. And they already gave me f prime of x right here. So if I let f prime of x equal 1 minus ln x, remember to do 0, I have to set the top equal to 0, and for undefined I have to set the bottom equal to 0. So let's do 1 minus ln x equals 0 first. So I'm going to take my minus ln x across, so then ln x has to equal 1. Then I'm going to e both sides to cross out the ln, so ln and e are gone. That means that x needs to be e. Now, e to the 1 is fine if you want to put that, but it's not really necessary. This is one of my critical numbers. Then I set the bottom equal to 0, and it seems like I have a second critical number. Okay, but that is not a critical number. Here's why. What did they say about the domain of the function back at the very beginning? It says let f be a function given by blah 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 for x greater than 0. So this is not a critical number because x is always bigger than 0, so I don't have to worry about that. Okay? Then it says, determine whether this point is a relative minimum, relative maximum, or neither. So I need to do a sign chart. So this is f prime. We are going to figure out what f is doing. Now, if I want a number that is smaller than e, I'm going to pick the square root of e for this section, and then when I want to plug in here, I'm going to use e squared. Because remember, if I want to pick a number smaller, I can take the square root. Bigger, I can square it. So we are plugging into f prime, which is right here. So I would have 1 minus the ln of e to the 1/2 over e to the 1/2. And then I would think about, okay, well, ln and e cross out. So really, that's 1 minus 1/2 over e to the 1/2. Well, think about 1 minus 1/2, that's positive. Then e to the 1/2 is positive, so that first interval is positive, which means that f would have been increasing. Then if I check my e squared, I would have 1 minus ln of e squared over e squared. Then ln and e cross out, so now I have a 1 minus 2. And it's 1 minus 2 over e squared. Well, then 1 minus 2 is negative, that's positive, so overall negative. Which tells me that for the relative min, max, or neither question, I know that this is a max. Now, it does say to justify your answer, so I'm going to make sure that I do that as well. So I would say x equals e. We have a relative maximum because f prime of x changes from positive to negative. Okay? It's a relative max because f prime changes from positive to negative. Okay, last part, we need to do actually two more parts. Part C says it has one point of inflection. Find the x coordinate of this point. So notice it doesn't tell us we have to justify or anything like that. For a point of inflection, I need the second derivative to equal 0 and also to change sign. Okay? So let's take the second derivative. We need to take the derivative of this, which you can guess is going to require quotient rule. So my high is going to be 1 minus ln x. My ho is going to be x. My d high, the derivative of that, well, the derivative of 1 is 0. The derivative of ln x is 1 over x, but it's a negative 1 over x. Okay, then the derivative of x on bottom is a 1. Okay, from there, I'm going to call this f double prime of x equals, and it's going to be ho d high, so x negative 1 over x minus high d ho, so that'd be 1 minus ln x, and then over ho squared, which would be x squared. Now notice I didn't write the times 1, but it's just because it doesn't make a difference. Okay? Then from here, my x's are going to cross out, but that's going to stay a negative 1 there in the front. So it's negative 1 minus 1 minus ln x over x squared. Now from there, I'm going to do one more simplification. If this is a negative 1 minus 1 more, then really that's going to be a negative 2. So negative 1 minus 1 more is negative 2. And then if this is a minus and my ln x was minus as well, now it's a plus ln x. Now when I find my critical numbers, remember they can come from the top equal to 0 or the bottom equal to 0. If I let negative 2 ln x equal 0, negative 2 plus ln x equals 0. I'm going to take my negative 2 across to the other side. So now it's ln x equals positive 2. And then to solve, to get rid of this ln, I'm going to have to e both sides. So e and ln cross out, x equals e squared. Now, from there, I go back up and it says I have exactly one point of inflection. So you would say, okay, well, if I set the bottom equal to 0, if I let x squared equal 0, then x equals 0 is a second critical number. But remember, doesn't count because it says that x is greater than 0. So I'm going to cross that out. This is my only point of inflection. Okay, then if you want to do a sign chart, you can. However, look at the way it's phrased. It said that I need to have one point of inflection and I need to find the x-coordinate. It doesn't tell me that I have to justify like the other one did, so I'm not going to. Okay, that's my answer. Now, part D says find the limit as x approaches 0 from the right of f of x, which is ln x over x. Okay, so first thing that I want you to think about is that if I'm doing x from the right, I need to think about what ln x is doing at that point. So, e to the x looks like this. ln x is the diagonal of that. So remember, I would flip it down. So if this has a horizontal asymptote, this has a vertical asymptote. So that means that as this graph goes down towards 0 from the right side, my graph is going down forever and ever and ever and ever and ever. Versus this point here, okay, it doesn't even really matter what's on the bottom. If this graph is getting bigger and bigger and bigger, then it's going to be DNE. And it doesn't tell me to justify, but that's because ln x has a vertical asymptote at x equals 0. And so remember, if that top graph is going crazy, okay, then it doesn't really matter what the x is on the bottom. Okay? I will help you do one other part of one of the other free responses. Hopefully you get the idea on that one. Let me check the other two out. Instead of doing the particle motion, I'm going to do the other one over here. So take a look back at free response number 1. Okay, I'm not going to do all of this with you, but I'll do a little bit of it with you. Okay, part A, you're taking f prime and f double prime. So f of x is equal to, if it's k square root x, that's really just kx to the 1/2. So I'm going to rewrite that. Kx to the 1/2 minus ln x. So let's take the first derivative. F prime of x equals, this is part A. 1/2 multiplies down, so now it's half k in the front. And then my x is now to the power of negative 1/2. Okay, then minus the derivative of ln x is going to be 1 over x. Now, you could simplify that more if you want to, but it doesn't say to, so I wouldn't do it. Okay, now let's find f double prime of x. I'm going to take my negative 1/2, I'm going to multiply it down on the 1/2 in the front. Now it's a negative 1/4 k. And then if I minus one more, that's like minusing 2 over 2. So that'd be x to the negative 3/2. Now, cross that out because you don't want the greater to be confused. Okay, here, if this is a 1 over x, that's the same. I'm going to do this as scratch work over here. 1 over x is the same as x to the minus 1. So when I take the derivative of this minus 1 over x, I'm going to do negative 1 times the negative 1 in the front turns to a plus 1. And then if it was already to the negative 1 and I minus 1 more, x is to the negative 2. Okay, and then leave it alone for part A, because if you simplify something wrong, you're going to end up losing all your points. Okay, part B. Part B says, for what value of k does f have a critical point at 1? For this value of k, determine whether it has a relative minimum, maximum, or neither. Okay, so I want you to think about a critical point, or a critical number, that's the same, is when the derivative equals 0 or undefined. That's the definition of a critical number. So they're telling me that I want to have a critical point when x is 1. So I'm going to take this equation here. I'm going to plug in that x has to be 1. And then I know the derivative has to equal 0, so I'm going to set it equal to 0. So it'll be 0 equals a half k. And then this is really a 1 over square root x. and a minus 1 over x, and then as I said, I'm going to plug in that x is 1. So if I plug in my 1 here, that's really just a half k. 1 over 1 makes no difference, then minus 1 over 1 is a minus 1. That's equal to 0, so I'll take my minus 1 across to the other side. Now positive 1 equals a half k, and then to get rid of the half, I'll multiply by 2 on both sides, which means that my k has to be 2 when my half and my 2 cross each other out. Okay, then it says, do I have a relative min, max, or neither at 1? Now, what I would not do is a sign chart. Remember that we talked about that concavity can tell you if a critical number is a min or a max. So if your graph is concave up, then your graph has to be a min. If your graph is concave down, then your graph has to have a max. So the concavity can also answer the question without me having to do a whole sign chart. And I already took the second derivative right here. So let's find that out. Okay, f double prime of 1 is going to be negative a fourth. Then when I get to k, I already know that k is a 2 now. Then my x to the 3 halves is going to be 1 over x to the 3 and square rooted, plus, and then this is a 1 over x to the 2. And then actually, since I forgot to plug in my 1, I'm going to switch this back to an x for now, and then I'm going to plug in a 1 right below it. Because remember, we don't want to put a 1 here if we still have x's here. So this is negative a fourth times 2 times 1 over 1 is just really a 1, plus 1 over 1, which is really just a 1. So a fourth times 2 is negative a half, plus 1. Overall, if I do negative a half plus 1, that is positive, because the 1 is bigger and it was positive. So that tells me that my graph is concave up, and remember that if my graph is concave up, it must have had a minimum. So now I'm going to explain that. Okay, so I'm going to say at x equals 1, graph has a relative minimum because f double prime at 1 is greater than 0. So f is concave up. Okay? And actually, let me fix this here. Is concave up around x equals 1. Okay? So remember, you can't be concave up at a single point. You have to be concave up around a point. Okay? Last part, part C. For a certain value k, the graph has a point of inflection on the x-axis. Find this value of k. So a couple of important things here. First thing I need is a point of inflection. And I know a point of inflection is when f double prime of x equals 0. And then it says it needs to happen on the x-axis. Okay, well I want you to think about that. If I'm on the x-axis, that means that my y value has to be what? Okay, hopefully you know 0. Because think about it, if I'm staying on the x-axis, any one of these points is going to have a y value of 0. So I know that y has to be 0, and I know that f double prime has to also be 0. So I want you to come back to think about, here's my second derivative that I had found earlier. I know though that y is 0. So I'm going to have to know more stuff about my graph than that. So I'm going to come back to the very beginning here and look at this guy right here. So let's take our 0 equals k square root x minus ln x. And let's try to solve it, because we know that our y is a 0 since we're on the x-axis. So I'm going to have ln x go to the other side. So I have ln x equals k square root x. And then my next step, I'm going to try to get k by itself. So square root x on bottom here, square root x on bottom here. Okay, these guys are going to cross out. Now, from here, I have a substitute for k. Now, where am I going to substitute into? Well, I know the second derivative has to be 0. So I'm going to come back to this original thing right here. I'm going to set it equal to 0, and when I get to k, I can't still assume that k is 2. That was my answer for part B, but that's not still true for part C. So I'm going to say 0 equals negative a fourth, and then when I get to k, I'm plugging this in right here, ln x square root x. Now, I have a 1 over, x was to the 3 halves, plus 1 over x squared. Okay, then from here, I'm going to make this look a little bit better. So this is negative a fourth, ln x goes on the top, and then down here, if I have the square root of x and x to the 3 halves, okay, I want you to just think about this for a second. That's x to the 1 half times by x to the 3 halves. So if I have both of these guys on the bottom, that means really that's x to the 1 half plus 3 halves is 4 halves. So really, that's an x squared on the bottom because 4 halves is the same as x squared. So I combined these two together to give me an x squared. Then plus 1 over x squared. Then I look at that and I notice, hey, look at my denominators. They're almost the same. What's the only thing that's wrong? Well, my second fraction doesn't have a 4, so I'm going to times by 4 on top, 4 on bottom. Now that these guys are the same, I have negative 1 ln x plus 4 over 4x squared. Then it says, remember that I have a point of inflection, but I only have one point of inflection. So I'm going to set the top equal to 0, negative ln x plus 4 equal to 0, and then I would set the bottom equal to 0. So 4x squared equals 0. Okay, let's solve both of those guys. So this is the top equal to 0, this is the bottom equal to 0. So I would take my ln x across, 4 equals ln x. Then to get rid of the x, I'll e both sides. E to the ln crosses out, it's just an x left over, which means that x is e to the 4. Okay, then it says from here, I want I want to find what x equals here, so I divide by 4. I'd have x squared equals 0. Then I square root, and I get x equals 0. But just like that last problem, remember, ln x is only true, or is only a function if x is greater than 0. So even though I did get an answer, if x has to be greater than 0, this is actually not a true number. And then from here, now that I have my e to the 4, look back at your instructions. They said for a certain constant k, the graph has a point of inflection. Find the value of k. They don't want this x value. They want a k value. So if that's my x value, I'm going to plug that in over here to my k substitute equation. So I would say k equals ln of e to the 4th square root e to the 4th. That would be your final answer. Whew, I got kind of nervous on that one, guys. I thought maybe I didn't know what to do. Okay, now here, you can simplify this further, but remember that since it's a free response question, you don't have to, but you can. So I'm going to cross out my ln and my e here. Really, that's just a 4 on top. And then on bottom, if it's e to the 4th square rooted, that's really an e squared. So this would be like a better answer, but if you're afraid that you're going to mess it up, okay, then I would just stick with this one right here. But both of these are correct, and it doesn't matter which one you do. Okay, good job. Happy Friday. Have a good weekend.